Welcome to this webinar in the Iliad webinar series. My name is Bente Lilja Bye. I'm going to be your host today. We are going to talk about how to connect ocean digital twins using a federated system approach in Iliad. But there will be also more general introductions to the topic. But of course, this is an Iliad webinar series, and we are going to use Iliad as an example. So today I have a very competent panel of speakers with me, as usual, and I will introduce them as we go along. But before we do that, I would like to present some house rules. We want to engage with you. We want you to ask us questions and to comment in the chat. And we are having the discussion at the end of the presentations. We have a series of presentations that are rather short, or less than 10 minutes each. So in the end, we will do the discussion. When you are listening to the presenters, please remember to mute yourself. And when we are starting the discussion, you can raise your hand and I will give you the floor to ask your question or to comment when we come to that. So with that, I will start to introduce Iliad a little bit first, and I will also show the program for you for the day, and I will share my screen in order to do that. Just hold on. Share like this. So today we are going to talk about connecting ocean digital twins using federated system approaches in Iliad. And the program is as follows. I will introduce you also to Iliad first, and then we will dive into the definition and learn about the concept of a federated system, and also the Iliad digital twins of the ocean federated system, and that will be done by Arne-Jørgen Berre from Sintef. Then we will talk about data spaces, Green Deal data spaces and Iliad. That will be presented by Joan Maso from CREAF. And we are then diving deeper into the components of the federated system a little bit in application packages in Iliad federated architecture by Marco Amaro Oliveira from INESCTEC. And we will then look at an external or a very important federated system, namely Emodnet. So we will have an overview of Emodnet with Conor Delaney from Emodnet. And then a discussion, as I said. To give you some context here, I will say a few words about myself also. I'm the innovation manager in Iliad, and I have a long background from the Earth observation community. I've been working in many different on many different application areas, but the red thread through my activity the last 20 years or so is making data interoperable. In digital twins, indeed, we need to make data interoperable. And the digital twins that we are creating in Iliad, we look at the definition, the very overall definition of a digital twin is of the ocean is to provide a virtual environment representing the ocean, capable of running complex predictive management scenarios. And the innovative system integrates across disciplines, sensors, models, regions, and digital infrastructures. So we want to make it interoperable, as I said, data intensive, indeed it is, and cost effective. So Iliad in the seashell, we can divide in three sections. We want to make interoperable digital twins, and we are using existing systems such as Emodnet, and also we are creating new data and systems. We want to offer this on a marketplace, and that marketplace will offer both the digital twins, the components of the twins, and the components that are being used in the twins. And of course, we are trying to, providing solutions to solve some of the big challenges related to ocean activity. I said that we are creating multiple twins, and the twins in Iliad are thematic and local. So they range from renewable energy, offshore energy, to coastal activities and harbors, or fisheries of food production in aquaculture and other catchments of fish. So a wide range of twins that we are developing in Iliad. We are doing this together with a lot of community. We are very open to engage with all the federated systems, the systems around us, and that's what Arne-Jørgen now will talk about. Arne-Jørgen is the senior scientist and the scientific manager of Iliad, and has long experience in ITC communities, in standardization, and of course, federated systems. So Arne-Jørgen, I will give the floor to you.
Thank you, Bente. I'll share my screen. I'll start with this. Here, I'll put that in presentation mode. Okay, started at the end here, that's fine. Okay, so you kindly gave me also the title of the concept of federated systems and the Iliad Digital Twin of the ocean in this context. So I have various definitions on federated systems, but I now, as a funny thing, I did the modern approach, asking ChatGPT. So what is a federated system? And the answer is not bad, actually. I mean, it's it collects definitions and put them together, and it highlights the point. A federated system is a type of distributed system, but where multiple independent entities collaborate to achieve a common goal while maintaining their autonomy. So autonomy is important here. Here are some key concepts and components often associated with federated systems, and we'll come back to that. Federation is a formation of a cooperative group of alliances of entities, organizations, systems that agree to work together. These entities retain their autonomy while collaborating on shared objectives. So autonomy means that each entity in a federated system remains control over its own resources, policies, and decision-making processes. Autonomy ensures that entities can operate independently and make local decisions according to their own requirements. And it implies also trust and security. That requires trust and robust security mechanisms. Participants must establish trust relationships and authentication protocols to ensure secure communication and protect sensitive data across the federation. Further, a focus on interoperability. Federated systems often involve heterogeneous entities with different technologies, platforms, and protocols. Interoperability refers to the ability of these entities to communicate, exchange data, understand each other's interfaces and formats. It implies also metadata and discovery. Federated systems may rely on metadata and discovery mechanisms to locate and access resources across the federation. Metadata provides information about available resources, while discovery mechanisms enable participants to find and utilize these resources. Data governance. Federated systems may implement data governance policies to manage data sharing, access control, data ownership, and compliance with legal and regulatory requirements. Data governance framework ensure that data is used and shared appropriately within the federation. And further, distributed processing. Federated system involves distributed processing, where the entities contribute their computing resources to perform joint computation, data analysis, or other tasks for efficient resource utilization and scalability. Federation management. Federation systems require management framework to handle the administration, coordination, and monitoring of the federation. This includes managing membership, resolving conflicts, enforcing policies, and monitoring the overall performance and health of the system. And federation agreements with entities in a federated system typically establish agreements or contracts that outline the terms, conditions, and responsibilities of participation. And these agreements govern aspects such as resource sharing, data usage, service levels, and dispute resolution. And finally, scalability and resilience. Federated systems should be designed to scale as more entities join the federation and to handle failures or disruptions in individual entities without affecting the overall system's functionality. So these concepts provide a foundation for understanding federated system, but it's important to note that specific implementation and architectures may vary depending on the context and domain in which the system operates. So I think this is a good overview of aspects of federated systems that we find to be addressed in many different situations, and also in such a large area as all of the systems under the ocean context, dealing now more and more with real-time data and digital twins. We see these as concepts that are important to relate to and support. So when we started out the Iliad project, we looked at and found a lot of these principles have also been established in the work on data spaces. And there is a number of books and recommendations and projects and activities that we'll hear more about later on how to design data spaces and how to use data spaces. It's also an analogy to the concept of data mesh, which is also a federated data architecture used maybe more internationally or in US than in Europe. In Europe, a lot of these concepts when it comes to data management are found under the topic of data spaces. And we will also see examples of this in use. We have the Gaia X and IDS reference architecture. And I will just highlight a few of the things that was mentioned in the concept description. There is support for identity and trust with identity provisioning and federated identity. There is sharing of resources, being both data and services through federated catalogs and harmonizing of that. There is also vocabularies for interoperability and different levels of interoperability, and a number of providers that will interact to support each other with their assets in being data and services in a distributed system with heterogeneous entities and autonomy and sovereignty. So this is something we will explore further. When we talk about digital twins of the ocean and also the UN work of DITO, the digital twin of the ocean is a virtual representation of the ocean and have an interaction with that short and long term. And will also embed both data and models and analysis. Can also be viewed as entities that will interact in such a federated system with a federation of multiple. It's not only one digital twin, there will be many. And indeed, in the architecture of Iliad, we are trying to support this with a lot of data providers, a lot of data lakes, a lot of sensor systems, both new sensors, citizen science and others. We see in particular with Iliad as a digital twin, the interoperation with the DITO, the European Digital Twin of the Ocean, which has a more centralized data lake to optimize performance with data and computation together, which is important for, let's say, global models of the ocean. But there are also other aspects that we will bring in when we have the more local and sector-specific digital twins, as we see in a number of the pilot areas that we have in Iliad, which is why we introduced the notion of the ocean data space as a federated system that will provide access to a lot of these heterogeneous resources that might be managed by various organizations that we work together. And of course, make this available for real-time representations with models, with simulations, with the what-if analysis, and with the local data lake for the real-time data and for the cache data for each data twin, which might not be the same data in each twin. So that means that we look into the data space that we will talk more about as the federated input. And of course, twins can also be part of the data and service catalog. So there can be a catalog of twins also, and federation and interoperability of twins. One of these twins typically being the large DITO European Digital Twin of the Ocean, which is focusing on bringing all of this data into a data lake and also bringing the various models into the engine so it all can support optimized usage, at least when we have the large need of data and large data sets that needs to be connected together. So we're now working on interoperability and say the federation between Iliad and Edito and others. And the emphasizing things of Iliad is particularly this federation around the ocean data space and how we can bring a lot of resources together for a set of twins, in particular also to support so-called local sector-specific pilots or local sector-specific twins, and also the interaction of that. So this is an issue that we have in common with a large set of other communities also, in particular the European data spaces, and we will hear more about input on that now from Joan next. We also have the Data Week 2023 next week, where we are organizing a session on digital twins with data spaces and standards, looking at how this is handled from the IoT point of view, what we do in Iliad with the data spaces and semantic interoperability, how this is being done in other projects and in other domains, because there is a lot of commonalities here of federated data spaces and federated digital twins. So this is kind of the foundation of why we think about federated systems in this context. And we will now introduce you to some specific approaches and kind of the more details of the data spaces activities through the All Data for Green Deal project that Joan Maso will talk about next. So that was my conceptual overview of federated system in the digital twin context.
Thank you very much, Arne. We see that artificial intelligence can be used in many different ways. You have probably noticed that I published a poll for you, so I will share the results of this poll. I asked you if you are familiar with federated systems or federated systems. And 49% of you actually have heard about it, but have no experience from it. So this is the typical, so the major part of you have this experience. And we have some that actually have been developing and contributed to developing federated system, 24%. And the next is somebody is using, 12% is using federated system. 10% is for the first time, and an unsure part also. So thank you very much for participating in our polls. We have polls, these short polls between each of the presentations to gauge to share information. Okay, so now we are going to learn about data spaces. We are going to talk more about what exactly do we mean by data spaces. And we have one of the experts here to do that for us, Joan Maso. He is a principal investigator at CREAF, and he's leading a specialized group in geospatial interoperability, GIS, and remote sensing. He has been involved in GEO for many, many years, a group on Earth observations. He has many activities related to citizen science, also an interesting type of data that needs to be included in our federated system. And with the hat today, Joan, I think that's the coordinator, well, partner in data spaces project funded by the European Union, but also as a coordinator of the Green Deal data spaces under the EuroGeo. So Joan, the floor is yours.
Yes, okay, thank you. Trying to find, okay, I believe I did. The presentation is here. This is an introduction to the data spaces and the Green Deal context. It's always difficult to have a presentation after Arne, because it's difficult to compete with him and his colorful and super detailed diagrams. I can only compete with him with an UML diagram, but this time I don't have anyone in here. I mean, the exercise of using artificial intelligence for defining federated systems is interesting, because if we go to the definition of the data spaces, we are going to see many things that were already said as the definition of a federated system. The Data Spaces Support Center defines a data space as an infrastructure that enables data transactions between different data ecosystem parties based on a governance framework. We We have heard about data transactions. We have heard about governance frameworks. So both are components of a federated system. If we go to the European Commission, they say that the act of bringing together the relevant data infrastructure and a governance framework in order to facilitate the data pooling and sharing is a data space. You should deploy data sharing services and tools, processing tools also. This is done by a number of organizations, not just one, and also to try and do a federated computer system that is eventually energy efficient too. So we are talking about cloud capabilities here. It requires, as a second bullet, to actually have a governance structure that needs to be compatible with the legislation in Europe, and also need to be transparent and use the first principles and respect the rights of everybody. And needs to improve the availability, data quality, and interoperability of data. So in practice, from a technical point of view, it's clear that data space is a federation of systems based on interoperability and government structures. Sorry for this slide that is very crowded with text, but the idea is that we have here a set of design principles that should guide the data spaces that are starting to exist and are going to exist in Europe. There is a need for data control. So tools for pooling, access, use, and share data should use open standards and be findable, accessible, interoperable, and reusable. But those tools should also ease the upload of information, as well as the revoke of authorization if new conditions take over. We have to take into consideration that the Commission here, the European Commission, is trying to reconcile the idea of open data and free data in Europe with the idea of the digital economy based precisely on the circulation of this information. So we need to have the data open, but we need to also to have some control on this circulation and some deals that allows us to trust partners and eventually enable some kind of monetization. This is more difficult in the Green Deal data space with the openness is paramount, but other other data spaces has other priorities. And if we review the list of data spaces foreseen, you will see immediately these differences. The second principle is governance. So again, we need to ensure the fair and transparent and non-discriminatory access to the data sharing. We need to respect the European rules. That means the personal data protection, the fundamental rights, the environmental protection, the competition law, and the international trade agreements for you, and probably more. The following the design principle is this technical data infrastructure. So that means that we will create an infrastructure based on building blocks that will try and use cybersecurity by design and also GDPR by design. We need to interconnect and interoperate. So it's clear that we need to conform international standards precisely to enable the first principles and to enable the exploitation and interconnection of the data and avoid the fragmentation. And we need a culture of openness among organizations and individuals, and that means the right licensing on your data to guarantee that it continues being shared and avoiding potential lock-in. 9 data spaces are the ones foreseen at the beginning by the Commission. So we have health here, where of course security and privacy is really important. We have industrial and manufacturing, where the component of the business and digital economy is more existing probably. Also in agriculture and finance, we have mobility, we have the Green Deal, we have energy, we have public administration and skills. Those are the ones foreseen, but some new ones are joining the club, like media and data space, cultural heritage data space, and even the remote sensing data with the Copernicus data space ecosystem that is again a federation. But we do not have any marine here, you see? No marine. So where the marine topics are, we have to understand that the marine topics are part of the Green Deal. There is this aim of the European Commission to become the first resource efficient and competitive economy without net emissions of greenhouse gases by 2050. And we know that the challenge is these vast amounts of diverse and distributed data resources from many stakeholders, many sectors, many application domains, and governance schemes. So we are seeing here one little fish that is part of the constellation of the different topics, including renewable energies, agriculture, and many more that are part of the Green Deal and will require to be part of the Green Deal data space in terms of data access, data processing, etc. So this is the objective. The objective is to solve the fragmentation and inconsistencies, and to break silos and enable data processing in this circle of the different topics that the Green Deal covers. This is my recipe to actually build a data space. First, you need to bring the actors together: public, scientific, citizens, sensors, space agencies. Those are the ones that bring you the data and the data services. Then you need to set a legal framework, maybe some kind of a directive, like the Inspire Directive or the High Value Datasets Directive, etc. Then you need to identify the data sets. Those needs to be machine readable, so the effort on metadata is really important. And again, this was emphasized by Arne before. You need to prepare a technical interoperable infrastructure that will enable data sharing, data semantics, cloud processing, etc. And you need to define the government structure in terms of rule purposes for participation, access, and the sustainability of the whole thing. So Iliad, from my point of view, Iliad should be considering itself as a part of the Green Deal data space. So the data space is structured in nodes. Those nodes are communicating together. They are sharing the data among those nodes with a set of rules. And I imagine an infrastructure with some of those nodes has the Iliad logo on them. They are digital twin of the ocean nodes. I also believe that the fact that the Iliad is part of the Green Deal could benefit it by using the authentication services and the services enabling the digital economy that the Green Deal data space should at some point provide. This is a diagram that tries to compete with the complex diagrams from Arne, but fails miserably. That is here combining a diagram from the International Data Spaces Association, where in the bottom part we have certified authorities, you have certification status protocols, you have the generation of tokens, you have the logging files to actually trace the activity, and you have a set of participants registered in this information about participants module. And all these things are interconnected into some virtual node that enables the circulation of data, maybe the circulation of data that is mainly a coverage, how it's called, data cube approach. Maybe it's more about sensor data, maybe it's more about data visualization, There is not much talk about data visualization in data spaces, but I believe it's an important component that needs to be added somehow. You will need also analysis components. You will have integrated clients that actually query all these services using the certifications that are provided in the data space, and of course the metadata catalogs that were emphasized before. So we need to reconcile somehow or use together the perspective of the general IT data spaces provided by the International Data Spaces Association with the geospatial/environmental web services and APIs that we all know and we have been using for quite a while in the past, coming from the OGC mainly, and also the ISO TC211. And as I said, some of those nodes could have the Iliad brand, because those are Green Deal data space nodes, for instance, a catalog of marine products there, or maybe a processing facility in Iliad. Those are just two examples that doesn't try to be exhaustive. Yes, so Bente, you were unsure if I was the coordinator of the Green Deal data space. Let me confirm you that I am. I also volunteered to chair this thing about the action group in Eurogeo about the data spaces. All Data for Green Deal is actually one of the 4 sister projects in the same call that are proposing slightly different solutions for different sectors. For instance, usage in particular is a project that works more on urban environments, while VCube is more in biodiversity. FeriCube is more in structuring remote sensing, Earth observation data cubes, and All Data for Green Deal is partially interested in situ data, but also on the other components. We are collaborating with the Green Deal data Space Foundation and its community of practice, something that is called the GREAT. They are going to provide a blueprint on how the Green Deal data space will look like. We have the support of the Data Spaces Support Center, and there are other projects like OpenEarth Monitor, EO for EU, Eiffel, Iliad, that are actually part of the of this group of people that regularly meet somehow and discuss how to move forward this idea of data spaces. So thank you for allowing me to be here.
Thank you very much, Joan, for this very nice and useful overview of data spaces. I also had a poll while you were speaking, Joan, and I will share this results with you now, because we asked if people here are familiar with data spaces. And we see that 28% have heard about it. There's also some, the second largest percentage is 26% say that they are not using data spaces per se, but using other similar approaches for data sharing. So there is.
And Bente, if I may help you to assess this result, I will be very surprised that people say that they are using data spaces, because this is a very new concept, and most of the data spaces are still on the drawing board. So that explains that people heard about them but has no experience. I believe that's the situation.
Yeah, the situation. Yeah, well, I have to say, since you said that, Joan, that in other continents, they claim that data spaces has been in use for a long time. So I think we have different notions depending on which regions of the planet we come from also. And now we are in Europe, so it makes sense, as you said, that it's very few who is actually using data spaces, maybe in an early stage. But there are also a group here that are developing data spaces. So I guess we have several, both in Iliad and in other projects. And we also have some newcomers. This is the first time they hear about data spaces. So a good distribution. So thank you again for participating in our polls. And now I guess we could say that we are going to dive even deeper into the federated system, or in another component, I would say, also related to data spaces. But that's what Marco Amaro Oliveira is going to talk about, application packaging. Marco is working at INESCTEC. He is leading an area called human-centered computing and information science. In Iliad, he is leading the work on modeling. We have a work packages on modeling, simply said. And this is also his starting point for the presentation that he will be giving. Yes, I think that's it for you, Marco. Sorry, we are excited to hear about.
Yes, that's my cue.
Yes.
Okay. First of all, I'm not a modeler. My background is on information systems and computer science. But I will talk about application packages in Iliad Federated architecture. I was almost tempted to get a snapshot from Joan presentation, where he has the connection between the data spaces connector and the WPS or OGC API processes in his presentation, because it's about that vertical that we are going to talk about right now. So by developing in Iliad a reference infrastructure for allowing for the packaging and the description of the models or any other applications that require processing, we intend to allow for within this infrastructure or architecture, sorry, to allow an efficient packaging and description of the application processes. Also to enable that those applications are registered and findable through APIs that I will talk a little bit more afterwards. And after finding these applications, allowing for them to be deployed or updated in computing infrastructures. This should allow us also to develop multiple scenarios of execution, both through the APIs or in cloud computing or HPC computers, or even in the Kubernetes clusters, for example. And then afterwards, using or through the data spaces have access or allow access through to the results that those processing applications produce. All of this is using open standards and known best practices, most of them from OGC. So what is an application package? An application package is a description, a textual description that is platform independent, that is self-contained, and that allows the representation of an application. It provides the inputs, the outputs, the software items that are required, which are executable, which dependencies they have, and all the metadata that are required for that application. This is using the application package format of OGC. That is a common workflow language implementation. It also requires to have those software items containerized in one or multiple containers, as we will show afterwards as an example application. And this is implemented by, of course, a software engineer, and it needs to have the outputs of the modeler, that is the model, the configuration files, and the executions that are already running in their infrastructure. For the common workflow language file, well, as I said, it is portable, it is scalable across multiple software and hardware components. It can run in many kinds of environments. It can run on my workstation, or in output on private or public clusters, private or public clouds or HPC environments. It can be deployable through OGC processes part 2 and findable, for example, through OGC API records. So as for the components of interoperability and making the bridge with what Joan presented before me, so that vertical pipeline that connects and between the processes and the data spaces infrastructure will be these API implementations. That's what we are using at the moment. For an example, so to describe an example of what would be the execution and the pipeline of development of an application package. So Antonio, that is a model developer, so a modeler, he develops and uses his software to describe and process, for example, an oil spill scenario. Then Alice, a software developer, that gets the outputs from Antonio, and she will containerize these processes in one or multiple software containers, so that in these containers they can be shared through a repository and can be run virtually anywhere. She also describes this application package, describing which inputs it requires, what will be the outputs, also every metadata that is required for sharing this application, and these will be outputted as a CWL file. Both elements here will be available through the repository if they are containerized applications, and through a registry that will allow us to afterwards find and request the execution of these containers. Alice will also get these free application packages and produce a pipeline by dividing the initial model into different containers and different application packages. She allows that others can provide different pipelines based on the description that each of the application packages have on their own. So this last application package that has no container attached to it, it's just the process, also can be shared as a tool for others to use. Others, for example, Jen, that is an analyst that needs to run and can deploy these applications or these packages on or through the OGC API and make it available also as a process for others, or as Bob, and I will show a small example. Bob finds the CWL file or the application package through the registry interface. Then he accesses his own private cloud or a public cloud where he can run his applications. And I will open here an application, and sorry, where is the browser? It's here. So I have here a small example of this pipeline that I have drawn on the backend. These are the three different CWL files and the pipeline overall. So I'm acting as Bob here, and I'm requesting to run this tool using a set of inputs to the requests here. And I'm running this. It will fetch, sorry, wrong password. Okay, it will fetch the containers. It will run the containers on the backend. I will continue with the presentation. So Bob will request execution of that application package. the application package will run, it will provide Bob with a stack file, a spatial temporal asset catalog that describes the output or the multiple files that are outputted from this processing. And in this case, this is just a simple scenario that will provide an oil spill description over time as an animated file. So the other, it's still running. It takes some time. I will leave it here running so that afterwards we can check on the output of this file. As a conclusion, and I'm already over my 8 minutes, we have here an architecture that allows us to containerize and the applications and to provide descriptions for it so that they are findable, so that they are usable virtually anywhere in different and multiple execution scenarios, and the access to the results might be available through the data spaces that were already talked about. This also allows us to ensure the reproducibility and the reusability of those pipelines and the data that are underlying and used within them. So with this, I finalize the presentation. Thank you. Not sure why I can. Okay, here it is.
Thank you very much, Marco. We really got this picture, this overview, this general overview, and then we looked with you, definitely, even with some code, Joan, I mean, and real-time processing. So this is really showing the whole spectrum live. So thank you for that, Marco. And I didn't want to disturb your explanation, so I posted the poll a little bit late, but I see that we have some answers now, so I will also reveal the results of the poll before we enter into the last presentation. We asked if you have experience with application packaging or containerizing in some sort. And we see here that most answered no, 40% no, 30% have only heard about it, and 30% are actually using it. So we have some newcomers, and we also have some experience within this community, which is great, a good distribution. So thank you again for participating.
Thank you all.
Yes, thank you. Now, we are going to look at another federated system, if you like. We are going to an external source that Iliad will for sure use and connect with several of the twins that we are developing in Iliad. And that's our next speaker is Conor Delaney. And he is the technical coordinator of the Secretariat of the European Marine Observation and Data Network, famously known for Emodnet. So, that's about sharing marine data in the European, and it's under now the European Directorate for Maritime Affairs and Fisheries, DG Mare. And you have, Conor has a long experience on big data, and environmental science combination and thereof. So with that, Conor, I give the floor to you. Thanks for being here.
Thank you very much, Bente. Can you see my slide?
Yes, we can.
Okay. So I'm going to give this overview of Emodnet, and then I'm going to dive in a bit technical aspects of it all in order to get to the questions which I want to ask, which are in slides 12 to 14. So please bear with me on this. I also see from the audience that quite a few colleagues and past colleagues are here as well, so I should reach out and say you'll be familiar with a few of the slides here. So Emodnet is an operational service delivering marine data, information, and knowledge for research, policy, blue economy, and society. So what this means effectively is that we are collecting and aggregating data over 7 areas in the coastal zone, from the seabed up to the top of the water column. and human activities in that area too. We're getting data sets from hundreds of data providers and aggregating to make them harmonized and standardized. And we cover basically the European seas and beyond. So when I say beyond, Europe has interests in the seas outside of the European zone, like there are territories in the Caribbean, for example, which we are looking at too. On a very high level here, we follow the INSPIRE standards for geospatial sharing. We follow FAIR data principles. We have harmonized multi-parameter data sets. We have searchable metadata. We use data services. We have integrated data products. The web service we use are OGC mainly. And to give you a bit more of insight here and to think about it in terms of a European Commission perspective, I'm here speaking about a European Commission service. And if you think about it for a moment, member states of the Union are only obliged to publish data and information about their territorial waters. There's no obligation on them to create aggregated data sets for the whole of the European seas. So our role in Emodnet is to take all these data sets and data products and create European scale products that are available for all to use. So another slight insight here is on what's the value in doing this. So what you're seeing here is a vessel density map. So ships have a thing called an AIS transponder. It's a little VHF transponder on the ship used to warn other ships about their relative positions. It's done to avoid collisions. So to collect the data is quite straightforward, but to aggregate the data is very difficult. And then to turn that data into maps where you can look at vessel densities and their pathways is a big data problem. So Emodnet produces these maps as a common good to the marine community. It's easier for us to get the data, aggregate the data, and publish these maps than it is for individuals on projects to do it. So that gives you an insight of the type of value we add onto this. So we then work on delivering data products and information that can be used in different aspects of marine management and marine exploitation in Europe, where you're looking at a European scale. If you just think about things like where are we going to put wind farms, or where are all the aquaculture farms, or where are all the ports, these are the type of things which we have in Emodnet. And up to this year, Emodnet existed as several separate portals. And as of January this year, it's now one central portal. And this is important later when I talk about the technical background. And you now can access everything that's in Emodnet through one central portal, which is hosted on the European Commission domain, which makes it a service of DG Mare. So the importance of that is, as being a service of DG Mare, it's here to stay. It's not going anywhere. It's not a research project or an external project. It's an operational service. So as part of our unifying Emodnet, we brought together the key information from all the separate thematics, which are 7 separate thematics, into the one portal, creating new sections in the portal for each of those thematics, and also brought together all the key information, say on web services, technical documents on how data is shared, documents on what metadata to use, what tools to use, all brought together into one portal. Before, you had to go to separate portals to get all this. And this is part of the Commission's policy to try and improve the speed of access for the citizens to these data and these data services. It didn't make sense for people to be sent all around the web to find stuff which could have been accessible through one central point. Part of that is we have one central catalog. We used to have 7 catalogs or 8 catalogs, including a central catalog. And as you see here, it's what's a geo-network catalog. Most of our services are OGC, so we're using OGC catalog services. And on the right-hand side, you see an example. There will be extensive metadata about each product that's in the catalog. We also have distribution information within the metadata so that you can either download data directly from the catalog, or there'll be information on the web services you can use to access these data products. So we follow in the centralization process, we follow a very loosely coupled architecture. And I'll just give you an example here and try and map it to the different technologies that the previous speakers were talking about. The very first image you see there at the top of the image is the map viewer on the central portal of Emodnet. Now we use the map viewer, it's not as a data discovery and download service. It's not a geographical information system per se. You're not doing any data processing or doing any knowledge discovery. It's for you to go there and find the data products that you're interested in and subset them and download them based on your area of interest. So in the first image there, you're seeing the digital train model for the seabed of Europe. Now, but the digital train model for seabed of Europe is an action that is taken by the thematic assembly group called bathymetry, and they take the hydrographic survey data from all the member states and from some commercial companies and create a thematic a digital train model. The layer that you're seeing in the first image is a OGC layer going back to a web mapping service, a tile web mapping service. So the red and yellow section you're seeing. The black box around that in that image is the user defining the area that they're interested in, and that creates a RESTful API call to a technology in the background called ERDA, which subsets the DTM, and then the user can download it in any format they want. The reason I bring this up is because all these web services are open access. You can use these web services in any application you want. You don't need to go through a map viewer. We publish the services. You don't need to log in to anything to use the services. You just need to understand how the services are called, and you can use them yourself. So we've published all the services up on GitHub, and you can go there to look at them, or we also have them all on the central portal pages, and most of them are OGC compliant web services. So I'll just give you a brief overview there. We have the central catalog. It uses catalog services for the web. Each of the thematic groups still have their back-end services, their back office services running. Even though the web portals are gone, the back office services are still there. So they still have web catalog services, which they update on a regular basis, and they populate with metadata on a regular basis. The central catalog harvests those catalogs and displays the outputs from those catalogs on this Emodnet website. If you can't access those or see those other thematic catalogs anywhere, you can actually probably harvest them, but to see what's in them, you need to go to the Emodnet website. We have data visualization services. We use OGC web mapping services. And once again, the back office services of the thematic lots are still there, and we're using their web mapping services. We have data download services. We use OGC web feature services. And some of the thematic assembly groups have web coverage services, not all of them. But we also use non-OGC RESTful web services. This is what I showed in the previous screen. There was a technology called ERDAP that we have the bathymetry DTM in, but there's also a technology called Threads that's also used. Both of these are OpenDAP standards. And then bathymetry also has its own RESTful API. Now, the ERDAP and the Threads technologies here, for people who are not familiar with the marine world, these are technologies that are widespread used by ocean data centers. There are at least 60 different ERDAP servers in operation in ocean data centers around the world, and they're ideal for sharing outputs from ocean models and weather models. So they're widely used. They're just probably not familiar to many people here. So we've got to the area where I want to ask my questions. So as you see, Emodnet, as I mentioned here, Emodnet is based on a federated technical architecture, but is it a data space? And I would argue that it is. Data spaces are based on flexible and decentralized architectures. Well, we have remotely hosted open geo servers, published OGC web services, which we consume. to provide the services through our central portal. We have data providers who offer their data to a market. Well, cheekily, I would argue that the Emodnet central portal is the marketplace that all the thematic assembly groups offer their data to. We have data consumers. Well, that's you and me and any other user who uses Emodnet. And then we have the central operator, which is the Emodnet portal, which creates a catalog, harvesting other catalogs, creates a map viewer for data discovery and downloads, and has a NerdApp server for data discovery and downloads. However, where we're different is in the governance models. We have no logins, and all Emodnet products are covered by open data. They are CC BY 4.0. So the only governance requirement on users is to reference by attribution the product that they're using in their whatever they're developing. So I would really appreciate feedback on this later on in the discussion, so because it would help us understand our place in the world of data spaces. But to go back to the federated systems, we are very definitely a federated technical architecture. On the far left there, you see where the end users are when they come to the Emodnet portal. They're using display services which we host in Belgium. Then we also host, for performance reasons in Belgium, some local services. But most of the services that we host, including most of the services like the catalog services, the web mapping services, etc., they're hosted in different countries all around Europe, based on where the members of the thematic assembly group are. So we're very definitely a technical architecture. And as a technical architecture, this causes us problems when we look to the future. So we're particularly always aware of performance. We have tools for monitoring the performance of our network, and sometimes some of the servers that we're using are not as performant as we want them to be. And also looking forward to the digital twins, we understand that the digital twins, especially those who are using machine learning models, will put an awful lot of will impact the performance of our demands on our servers. So we have opened up a conversation with Copernicus Marine about 2 years ago to look at this, and this is where the Ditto Infra idea came along. We wanted to make sure that we were able to have a complementary service to what Copernicus Marine offer and what Emodnet offer, where we could store and publish the products from both services in a very high performance data lake that could be used and utilized by people who want to do machine learning algorithms or machine learning modeling without impacting on the services that we already provide to our traditional users, which tend to be in the geospatial world. So the reason why I bring this up is because we never really chose to be a data space or a distributed technical architecture or a marine data lake. We're just faced with technical challenges, and these are the architectures that we became aware of, and we decided these were worth looking at to see if we could use these to meet the technical challenges. So I'm happy to answer any questions anybody has on the logic of our thinking, whether it's positive or flawed, and are we really a data space, which I'm happy, hopefully you community will tell us. Thank you.